Hello APC Mechanics students in Unit 1 Kinematics, Class 13, Motion in 2 Dimensions, Part 1. Section 1, Variables of Motion in 2 Dimensions. Variables of motion like position, displacement, velocity, and acceleration have been represented previously in 1 dimension. Now we will represent them in 2 dimensions. Consider a particle as moving in a 2-dimensional Cartesian XY plane generated by the basis OIJ. Then this is the plane consisting of X and Y. These axes X and Y, since they are related to direction, are being generated by the base unit vectors I and J. I is generating the x-axis and J is generating the y-axis. The location of S is determined by the Cartesian coordinates X and Y. So this is the particle X existing in this plane. We can associate with it a variable X and a variable Y, and this is said to be the position. Trajectory. The trajectory is the path followed by an object. In a 2-dimensional plane, the trajectory is an equation relating the variables x and y. Y is equal to yx is the trajectory equation. So suppose that the particle S is gonna move along this path. The followed path by the particle is known as the trajectory. Examples of relevant trajectories: straight line, that would be linear in x and linear in y, like y is 3x plus 2. This is a linear trajectory. Circular one, which is gonna be trigonometric in x and in y. And parabola, that would be linear in x and quadratic in y, or vice versa. For example, y is x squared plus 3. This trajectory is a parabola, and let's say that y squared minus 2 is equal to x, which is linear in x and quadratic in y. That would be also a parabolic trajectory. Now we are interested in introducing the previous variables of motion in 2 dimensions. The position vector is given by r, is given by x vector plus y vector, which is the variable x multiplied by the unit vector I plus the y, the vertical position multiplied by the unit vector j, and this can be represented on the diagram starting from the origin. The tail would be the origin and the head would be the particle itself, or the center of mass of the particle. Now what about the velocity? So here we have the particle S, we have the trajectory, and we have the position vector. Now how can we represent the velocity? The velocity in this case, it lies in 2 dimensions. It has an x component, y component, and can be written as the variable of motion velocity Vx multiplied or generated by the unit vector I multiplied by I plus Vy multiplied by J. So I have represented the trajectory here. I will explain why I have represented it like this, where Vx is the velocity along the x-axis and Vy is the velocity along the y-axis. So the velocity vector can be decomposed into 2 parts, Vx and Vy. Vx would represent the velocity along the x-axis and Vy would represent the velocity along the y-axis. And here we have represented the decomposition. Then the horizontal part of the velocity would be Vx and the vertical part of the velocity would be Vy. And the velocity has a direction tangent to the trajectory. For this reason, I have represented the velocity in this way. It's almost tangent to the trajectory, okay? Now, let me repeat myself and say, whenever we say velocity, we mean the big velocity, which includes both Vx and Vy. So we have 2 velocities, Vx and Vy. And what about the speed? In this case, we know that the speed is the magnitude of the velocity here. Because we have 2 velocities, Vx and Vy, the magnitude for a vector is given by the Pythagorean sum of its component. Then in this case, the speed, which is the magnitude of the velocity, is calculated using the Pythagorean sum, which is radical Vx squared plus Vy squared. Okay, because we cannot say that the speed is just Vx or the speed is Vy. The speed is both Vx and Vy, so we need to add them. But since they are components of a vector, how we're gonna add them? We're gonna add them using the Pythagorean sum. Now what about the acceleration? The acceleration is given by a, which is ax plus ay. So here we suppose that we have 2 accelerations, partly along the x-axis and partly along the y-axis, where ax is the acceleration along the x-axis and ay is the, that should be the acceleration along the y-axis. Now the magnitude for a vector is given by the Pythagorean sum of its component. If we need to discuss the magnitude of the acceleration, so it would be ax and ay, then we need to add them. And how we're gonna add them? Using the Pythagorean sum. Then the magnitude of the acceleration in a 2-dimension would be given by a, which is radical ax squared plus ay squared. Now what about the displacement? Consider the two position vectors r1 is equal to r vector at t1 and r2 would be r vector at t2 where t2 is a later time. So initially the position of the particle s was here and it moved to the final position 2, and we are interested in the displacement. We know that from the previous method the displacement can be determined from tail to head method. The tail would be represent the initial position and the head would represent the final position. Then that would be the displacement vector delta r. Then the displacement is given by delta r, which is r2 minus r1, which is x2 plus y2 minus x1 plus y1, because the position vector r2 is given by x2 plus y2 and r1 is given by x1 plus y1. And here we have represented delta r graphically using the tail to head method. Now example 1, for each of the following cases indicate the type of the trajectory, straight line or parabola of the moving particle as described by the coordinates x and y. All quantities are in the SI. So the question is very specific. We need to indicate the type of the trajectory. We no need to find the trajectory equation. So in example 1, we notice that x is linear in time and y is linear in time. So if we try to solve for t, it means if we try to find an equation that depends only on x and y, so that would give us a linear equation in x and in y. So for example, if we try isolate t here, so t would be given by x plus 3 divided by 2, and t, if we replace it back here again, so we're gonna have a linear relation by y and x, simply because x is linear in time and y is linear in time. So this means this is a straight line. Now similarly for part 2, x is linear in time and y is linear in time. If we try to replace t here in the first one or t in the second one, we're gonna get an equation which is linear in x and in y, which is a straight line. However, for example 3, we notice that x is quadratic in time, so if we try to isolate t here and replace it here, we're gonna get an equation which is basically quadratic in y and linear in x. So quadratic in one of them and linear in the other, which means it's a parabola. And for the fourth one, we know that we have that x is linear in time and y is quadratic in time. So if we try to replace one in another, we're gonna have that one of the variables, the equation would be linear in one of the variables and quadratic in the other, and that would be a parabola. Now in the next example, which is example 2, we're gonna find the trajectory equation explicitly. For each of the following cases, determine the trajectory equation of the moving particle as described by the coordinates x, y. All quantities are in the SI. Then let's start by 1. In 1, we need to determine the trajectory equation, and the way to proceed is to determine t from one of the variables and replace it in the other. We can determine t from x or we can determine t from y. So let me check. Okay, so basically both ways around it will work, but I referred to the solution just to have the same representation. Now if we try to isolate t by referring to x, so if we move -3 to the other side, that would be x plus 3 is 2t, and if we try to isolate t, then t would be given by x plus 3 divided by 2. Now if we replace 2 back here, that would give us y is equal to -4 multiplied by x plus 3 divided by 2 plus 2, which is the answer represented here. Knowing that also this can be attained by isolating t from this one. So y minus 2 is equal to -4t. I have dragged 2 to the other side. Dividing by -4t would be y minus 2 divided by -4, and this can be also represented as t is equal to -y plus 2 over 4. And if we replace t back again, then x would be given by 2 -y plus 2 over 4 minus 3. Knowing that both answers might look different, however, if you do the calculations and try to put them in the same form, like for example y as ax plus b, you're gonna see they have the same equation, and the trajectory equation is unique in this case. Now for example 2, then basically I have referred to this equation in order to isolate time. Then 2t would be given by 3x, and t would be given by 3x divided by 2. Now if you replace time here, that would be y is equal to 3 over 5t. Then y is given by 3 over 5 multiplied by 3x over 2. And that would be the answer. No need to simplify, even no need to divide 5 on the other side. We can keep it like this. And as you can notice that the trajectory equation only depends on y and x explicitly. As for question 3 or part 3, now here we can also isolate t from this or from that, but since this is a linear, so it's better to refer to this one. It's gonna be easier. So isolating t here, t would be given by y divided by 2, and replacing it here, then x would be given by y divided by 2 to the power of 2 of negative minus 1. Then that would be the trajectory equation for part 3. And for part 4, already t here has been isolated and it's given in terms of x. Then y would be given by x squared minus 1, and this is the trajectory equation that relates only y and x together. Now example 3, for each of the following cases, find the speed and the magnitude of the acceleration of the moving particle s described by the coordinates x, y. All quantities are in the SI. Then you know that speed is basically related to the velocity, and the magnitude of acceleration is related to acceleration. Both velocities and acceleration can be determined from the position using calculus. However, here, since we have two variables of motion x and y, and the motion occurs in a plane, then the speed would not be solely vx or vy, would be the sum, but which sum? The Pythagorean sum. Then in this case, in order to determine the speed, so first we need to determine vx and vy. Vx is related to the position via derivative, and that would be 2 meters per second. Vy would be negative 4 meters per second. That's the velocity for each component. What about the speed? The speed would be given by radical 2 square plus 4 square. And if you do the calculation, let me try to do it here. That would be 4 plus 16, which is radical 20. And that would be 2 radical 5 meters per second. So this is it for the velocity. Now as for the acceleration, so Vx is basically 2, then Ax would be 0, and Ay would be 0, then A, which is the radical of Ax square plus Ay square, would be 0 as well. So the speed is given by 2 radical 5 and the acceleration is given by 0. Now for part 2, okay, also we need to determine Vx and Vy, but in order to derive x, we need to isolate it. Then x would be given by 2t divided by 3. Vx would be given by 2 over 3. Now we need to isolate y. Y would be given by 3t divided by 5, and Vy would be given by, so this is meter per second, and that's meter per second. And if you try to do the velocity as radical Vx square plus Vy square, which is the radical 2 over 3 square plus 3 over 5 square. So you can do the calculation and compare. You're gonna get an answer, and its unit is gonna be meter per second. As for the acceleration, Ax is 0 and Ay is 0, which means that the total acceleration or the magnitude of the acceleration would be 0 as well. Now as for part 3, Vx is given by 2t. This is quadratic, so here we'll notice that we're gonna have an acceleration. In 1 and 2 we don't have acceleration because it's linear in both. And Vy in this case would be 2 meters per second. Ax would be given by 2 meters per second square, and Ay would be given by 0. So in this case the velocity would be given by 2t to the power of 2 plus 2 to the power of 2. So the speed will vary with time. This is because we have acceleration, and no need to simplify it. We're gonna keep it like that. And the acceleration is given by the radical of this square plus this square, which is 2 square plus 0 square, and that would be 2 meters per second, the magnitude of the acceleration. And now for the final part, Vx would be given by 1 meter per second, Vy would be given by 2t. Here no need to put a unit because Vy is represented in terms of another parameter. Ax would be 0 and Ay would be 0. Then V would be the radical of 1 square plus 2t to the power of 2. No need to simplify anything or do further calculation. And the acceleration in this case, sorry, that would be 2. And the acceleration, if you do the calculation, would be radical of 0 square plus 2 square, which is the radical of 2 square, which is 2 meter per second square. Alright, now section 2, circular motion. Consider a particle m of coordinates xy moving along a circle of center I, AB, and radius r. So here we have a circle. R is the radius of the circle, I is the center of the circle, having position given by the coordinates AB, and this circle for sure it lies in a 2-dimension, and the particle which is moving is m, having the positions x and y. The trajectory equation or equation of a circle is given by the constraint equation. So this is the equation of the circle. X and y are variables and they represent the position of the moving particle m. A would represent the abscissa or the axis of the center, B would represent the ordinate or the vertical position of the center, and I would be the radius. Now the kinematics of a circle can be expressed in the polar coordinates. The polar coordinates are given by r theta, where theta is a function of time and it is the angle between the line IM and the horizontal line of equation y is equal to b. Now previously all of the motions have been represented in what is known by the Cartesian coordinates x and y. However, because we're moving along a circle and we can make use of the symmetry of the problem, it's better or more convenient to represent the motion via polar coordinates known as the radius of the circle, which is fixed, and by the angle which the particle makes along with the horizontal axis passing through the center. So if you think about it in this way, if m is said to be moving along a circle, as it moves along the circle, both for different positions along the circle, both x and y, they will vary continuously, but they are related via the constraint equation. However, if you consider the polar coordinates r and theta, r will be fixed, which is radius, like 2 centimeters, 3 centimeters, it is fixed, and the only variable would be theta. So whenever we're talking about circular motion, it's good to refer to the polar coordinates known as the radius and the angle. However, Cartesian coordinates x and y and polar coordinates r theta can be related via the following transformations. X is r cosine theta plus a, y is equal to r sine theta plus b. We need to know the relation between, so we have two representations, Cartesian given by xy, polar given by r theta. We should know how that these are related to each other. So x is given by r cosine theta plus a and y is equal to r sine theta plus b. What does a and b represent? They are the coordinates of the center of the circle given by IAB, and r would be the radius of the circle, theta would be the angle of the moving object. R is in meters, is the radius of the circle, theta is in radians. Remember that angle can be given either in radians or in degrees. Always whenever we're referring to dimensional analysis and SI units, theta would be referred to be in radians. A, B are the coordinates of the center I of the circle, both expressed in meters. So the unit of A would be in meters and the unit of B would be in meters as well. Notes regarding circular motion. So how can we know that we're talking about the circular motion? 1. Once the functions cosine and sine appear in Cartesian coordinates, one should directly think of circular motion. Then whenever x and y, they are given as or in terms of these trigonometric functions, you should directly think of circular motion. It doesn't mean it is necessary dictated by circular motion, but you should think or considering this option. Therefore, note 2, but it is not a general rule. The key point is that both cosine and sine should have the same coefficient and the same angle. So given the following representation, that relations that relate two different representations, the Cartesian with the trigonometric. How can we know that we're talking about circular motion? So first you look at the coefficient. If the coefficient is the same and the angle is the same for both cosine and sine, which means that we are talking about circular motion, and I will explain myself more in the coming example. Note number 3, a useful equation when considering trigonometric functions is cosine square theta plus sine square theta is equal to 1, which is known also as the Pythagorean rule. So cosine square theta plus sine square theta is equal to 1 holds whenever the angle is the same. So suppose I say cosine square theta plus sine square theta, or let me say 2 theta, that would be not equal to 1 because both angles must be the same. Alright, so this relation always hold whenever the angle is the same. If the angle is not the same, it's not gonna work. Idea 4 or note 4, the velocity is always tangent to the circle, which is the trajectory. So remember that the velocity, we have said previously that the velocity is always tangent to the trajectory, and here because we're talking about circular trajectory, we can notice that in this animation across all points the velocity is tangent to the circle, and this object is rotating counterclockwise. Now example 4, given the position xy of a moving particle s in a two-dimensional plane, state for each of the following examples if the governed trajectory is a circle or no. All quantities are in the SI. We need just to state, no need to do any calculation. Then let's take a look at the first one. So the coefficient for, remember that I've said that the coefficient should be the same, the angle should be the same. The coefficient is 3, the coefficient 3. However, the angle is different. Then in this case, this is not a circular motion because we have different angles. What about example number 2? So the coefficient is the same and the angle is the same, which means that this is a circular motion indeed. Same coefficient and same angle. What about example 3? The coefficient is different, so directly it's gonna be non-circular motion because the coefficients are different. So here in this case, the coefficient is the same and the angle is the same, and we don't care about anything else. Then in this case, yes, indeed, it's a circular motion, same coefficient and same angle. Example 5, for each of the following examples, determine the trajectory equation of a moving particle s whose coordinates are x and y. If the trajectory is a circle, indicate the center and the radius. All quantities are in the SI. So if you refer to the question carefully, although I've read it fast, we need to determine the trajectory equations, and then we need to find the equation of the circle explicitly. And if it is a circle, so let's investigate directly. Same coefficient, same angle, so this is a circle. Same coefficient, same angle, this is a circle. Same coefficient, same angle, so this is a circle. Then all of these examples are a circle indeed. Then for each one we need to determine the trajectory equation, and we need to specify the center and the radius. Then let me remind you that the trajectory equation for circular motion is given by, so let me write it down because I'm gonna use it here. So x minus a square plus y minus b square is equal to r square. A and b are the coordinates of the center, r is the radius, and we're gonna make use of this equation, which is cosine square theta plus sine square theta is 1. Then let's start with part 1. Now the key point in solving this problem is to isolate cosine and to isolate sine and replace them in this equation. So in this case, if you drag negative 2 to the other side and divide by 4, then cosine 3t would be given by x plus 2 divided by 4. And for this one, if you take negative 5 to the other side and divide by 4, that would give us sine 3t is y plus 5 divided by 4. And now we can say that cosine square of 3t plus sine square of 3t is equal to 1. I will replace now cosine by that and sine by that. We would have x plus 2 over 4 to the power of 2 plus y plus 5 over 4 to the power of 2 is equal to 1. Now let me complete the calculation here. Now the power 2 is for both the numerator and the denominator. That would be x plus 2 to the power of 2 divided by 4 square plus y plus 5 to the power of 2 divided by 4 to the power of 2 is equal to 1. Now 1 can be written as 4 square divided by 4 square, and we can simplify by these. And as you can notice, we have achieved the following form. So x plus 2 square plus y plus 5 square is equal to 4 square. That would be the trajectory equation. Now what about the center? So if you compare, you will notice that negative a is equal to 2, which means that a is equal to negative 2 meters, and negative b is equal to 5, which means that b is equal to negative 5 meters. Then the center is given by negative 2 meters, negative 5 meters, and the radius 4 square is equal to r squared, then r is given by 4 meters, and that would be the answer. This is the trajectory, this is the center, and this is the radius. Alright, now for number 2, okay, I'm gonna do it here. So the key point is to isolate cosine omega t and sine omega t. Let me do them fast. Then cosine omega t would be given by x divided by 2r, and sine omega t, if you take negative 1 to the other side and divide by 2r, that would be y plus 1 over 2r. Now if we use the rule cosine square omega t plus sine square omega t is equal to 1, then we're gonna have that x over 2r to the power of 2 plus y plus 1 divided by 2r to the power of 2 is equal to 1. Now 1 can be written as 2r to the power of 2 divided by 2r to the power of 2, and the power 2 is for both the numerator and the denominator in both cases. We can cancel this with that. Then x square plus y plus 1 square is equal to 2r to the power of 2. And let me write it in the following form: x minus 0 to the power of 2 plus y plus 1 to the power of 2 is equal to 2r to the power of 2. And I have added the 0 because I'm writing it in the following form: x minus a square plus y minus b square, which is equal to r square. Then in this case a is 0, b is negative 1, so because minus b is 1, and the radius would be the double of r, then that would be the answer. Now in number 3, we're gonna do the same thing. So sine omega t would be x divided by a, and cosine omega t would be y divided by a. And if we make use of the fact of sine square plus omega square for the same angle is equal to 1, then that would be x over a to the power of 2 plus y divided by a to the power of 2, that would be equal to 1. A can be considered as a square over a square, this simplified with this with that. Then x square plus y square is equal to a square, and representing it in the form of x minus 0 square plus y minus 0 square is equal to a square, which means that the center is given by I, which is 0, 0, and the radius would be given by a. Now exercise 1, an object with an unknown initial velocity has a constant acceleration with components ax and ay. Which of the following is a possible expression for the position of this object in meters for both x and y directions as function of time? So we have the acceleration in each case, and we need to determine the corresponding position along each direction. I'm talking here about x and y. So if you think about it, going from acceleration to position it can be achieved by calculus via integrals, but you need to have information about initial conditions like initial velocity and initial position. However, we can do it the other way around since we have the answers, which is the choices. Then if the acceleration is a constant, which means the position should be quadratic because we need to derive it twice, then either this or this or this. Now what about the acceleration along the y? If it's 0, then the position should be linear because we're gonna derive twice. Then D would be the correct answer, and if you do the derivation, then Vx would be 80 and Ax would be 8 meter per second square. What about Vy? Vy would be 8 meter per second and Ay would be 0, so D is the correct answer. So always whenever solving an exercise, try to achieve it both way around, either from the given to the solution or from the solution and try to generate back the given. Exercise 2, a particle moves in a circle in such a way that the x and y coordinates of its motion given in meters as function of time in seconds are. So if you look carefully, now they have the same coefficient, same angle, so it's a circular motion. Now believe me or no, if you try doing the calculation, the radius would be simply the coefficient, which is 5, then the correct answer in this case is C. Now exercise 3, which is the exit ticket of today's video, a particle moves in a circle in such a way that the x and y coordinates of its motion given in meters as a function of time. We have x and y. Which of the following is true about the speed of the particle? So here we have combined motion in a two-dimensional plane. So if we're talking about the speed, we need to talk the velocity along the x-axis, velocity along the y-axis, combine them together using Pythagorean sum. and this can be achieved using calculus. So let me find Vx. Vx would be given by, so 5 is a constant, can be dragged out, and that would be, so this is a functional, we need to derive the inner function, that would be negative 3 sine 3t, and that would give us what? Negative 15 sine 3t. And as for Vy, you can do it the same way around, it would be 15 cosine 3t. Now V would be radical of Vx square plus Vy square, which is the radical of this and that, which is negative 15 sine 3t to the power of 2 plus 15 cosine 3t to the power of 2. And that would be, now if you take 15, so power 2 is for both 15 and sine, power 2 is for both 15 and cosine, then we can take 15 to the power 2 as a common factor, and that would give us, then the minus sign cancel with the power 2, that would give us sine square 3t plus cosine square 3t, and that would be radical 15 square multiplied by 1, which is basically 15 meters per second. So the speed is gonna be 15 meters per second, and we know that because the coefficients are the same and the angle is the same, it's a circular motion. Now here they're only asking for the value of the speed, so it is always equal to 15 meters per second. And the correct answer in this case is B. Then that's it for me in this video, guys. See you soon in a new one.